right. Hello, my name is Michaela McCoy, and today I will be presenting on the effect of human population size on male raccoon body size. We focused on Procyon lotor, which is the raccoon that is most common in the United States. This research was done by Alyssa Cluck and I over the last 2 weeks. So here's our introduction. It was expected that the urbanization will continue to increase as human populations continue to grow. With an increased urbanization, wildlife will be affected in several ways, whether it be through habitat destruction, increased temperatures due to human development, or loss of food sources due to decreased biodiversity. Studies have been conducted that show that animals living in urban areas have smaller body size and mass compared to individuals in a more rural and conserved area. And that body size of raccoons has been studied in response to seasonality. So their bodies have been found to fluctuate in weight depending on the seasons in different environments. The effect of urbanization on raccoon body size is not well known. So this is not something that's been studied a whole lot. But since raccoons are a common species observed in both urban and conserved areas throughout the United States, we wanted to see if urbanization affects their body size. So we hypothesized that raccoons seen throughout urban areas would have a smaller body size compared to raccoons in areas that are non-urban. We expected this due to the increased temperature, due to the buildings and pavement, the decreased food sources due to decreased biodiversity, and the increase in fatty food sources due to human waste. All right, so for our methods, we started by collecting specimens from VertNet, which is that database that Dr. Foray mentioned. So we set the database to look for Procyon lotor in the United States, and we recorded the city that each specimen was found in. We recorded the population of that city in 2020 or 2019, whichever was most recent. We recorded the year the specimen was found, which often was not 2020 or 2019, so we should have done a better job of finding the population at the year the specimen was found, but I'll touch on that more later. We recorded the sex of the raccoon that was found, so we did only record male specimens. That is because raccoons are sexually dimorphic, so the females are a different size than the males. So we wanted to keep it just one sex to prevent any kind of bias in the data. And we chose males because there were more males listed than there were females, and we wanted the largest population size for our data analysis as we could. So then we recorded the body length in millimeters. That's just what it was listed as in VertNet, so that's what we decided to go with. We also listed the body weight in grams whenever body weight was listed on the specimens. So I did find a few that didn't have body weights. Those ones we just didn't use for the body weight analysis. Okay, so once we'd recorded those, I reorganized the spreadsheet so that it would play well with the Excel ANOVA function. So we had to make the number of specimens in each group the same. So we started with 14 specimens in the urban population and about 50 in the non-urban population. So I had to cut the non-urban group down to 14. So to do this without creating bias, we just took the first 14 that were listed. I then used the Excel data analysis tool pack to run a two-way ANOVA on the data. We decided to do a two-way ANOVA because that's what was recommended to us. Looking back now, I think a one-way would have been fine, considering we only used the data from the two-way that we could have gotten with a one-way. So I think one way would have been better because all we needed was the p-value comparing group 1 and group 2. Our data wasn't set up in a way that a two-way would have worked for the body weight and the body length. All right, so here are our results. Let me move myself out of the way here for you guys. Okay, so our ANOVA found a p-value of 0.88, which is much greater than 0.05, which tells us that there was no significant difference between the body sizes of urban and non-urban raccoons. So I also plotted the averages that I found because I did calculate the averages just to like see what they would be. And the average body length, obviously you can see the small population had a very, very slightly longer body length, but it wasn't enough to really be a significant difference. And we also have the average body mass over here on the other side, which you can see the large population is slightly greater than the small population, but again, it's very, very slight and there is no like significant difference between the two. So those are our results. All right, and here is our discussion. So we found that raccoon body size did not differ significantly between raccoons living in areas with urban human populations and raccoons living in areas with very little human interaction. We did find some flaws in our research. Obviously, I discussed the one earlier about the populations, but we're going to start with sample size. So firstly, we had a very, very small sample size to base our analysis on. Like I said, we only had 14 individuals in the urban cohort. So we had to pare down from 50 to 14 in the non-urban cohort, which gave us a sample size of 28, which is very, very small. In an ideal world, that number would have been much larger. I would have preferred it to be into the hundreds, but BERTnet did not have as many raccoon specimens as we had hoped for. So many of the listings also did not say what life stage the raccoons were in. So for example, I collected all of the urban data, so all 14 of the urban listings, and not a single one of them listed what life stage the raccoon was in. Alyssa did say that some of hers listed it, but it was not the majority, to say the least. So we don't really know how old a lot of these raccoons were. We don't know if they were full grown. We don't know if they were so old they were shriveling. We don't know. So that could have greatly affected our data because we did have some that were kind of small and we did have some that were kind of on a larger end than the others. So that could have greatly affected the numbers that we got. So on to the next part, we did notice that some of the specimens were very old. I think the oldest one we found was from 1934. So obviously we don't really have population records from 1934, or if we do, they're very incomplete and they're far from perfect. So we did do our best to remove some of the older specimens, especially from the non-urban specimen list. We had one in the urban specimen list that was from 1948. I did find the population from 1948 and it was high enough that we could keep it. So luckily we didn't need to get rid of any of the older ones found in the urban population. But this could have very, very greatly affected our numbers. And if any of ours that were even slightly older, like we had a lot from the 70s and 80s, if any of those don't have the right populations, then that could have messed with our numbers too. And we didn't go and check those. We didn't think to do that. So that also could have affected our data. All right, so moving on to future research. It would be beneficial for the study to be redone in a different way. So I think a recapture study would be good, or capture and release, as I wrote on the presentation, would be beneficial. So I would say researchers go out and capture as many of them as they can in an urban setting and a non-urban setting, record their body weights, mark them, go back out in like a month or so, do it again, just see how many specimens they can get. And that way, if they are marked, they can just record if their body weight's changed. And I feel like this over time would be a lot more accurate than using specimens that could be almost 100 years old and incomplete data, because they could also record the life stage if they captured them in person. They could record all of these things and know for sure that that's what that specimen was. I think as far as research other than what we did goes, I think a nutrient study would be good. So, for example, one of the articles that I read while doing research for this project was about nutrient levels in sparrows in urban and non-urban settings. And they found no difference, but I think raccoons would be a better candidate, just because I personally have seen raccoons in trash cans. I know others have seen raccoons eating out of dumpsters and eating other human waste. So I think there would be more of a chance of them having a higher fat count and maybe a lesser nutrient profile than raccoons found in a natural setting where they have access to more of the food that they would consume without humans around. So I think a nutrient study would be really cool for raccoons. So that's all I've got for this presentation. Thank you guys so much for listening. I hope you learned something. I hope you enjoyed it. Feel free to leave me comments below.